All right, so today we are going to be adding fractions with unlike denominators. So I am going to pause the video for just a second because I want you to write all of these steps that you see over here off to the left. These 4 steps that are numbered are our steps to adding fractions with unlike denominators. And then down here, we talked about this last week when we were simplifying, about how if you get a prime numerator and a prime denominator, you're done and you're simplified. You can't simplify again. If you get a prime, well, really a prime numerator or denominator and a composite numerator or denominator, so one of each, you see if the one can fit into another. So for instance, like 3/9. 3 would be prime, 9 would be composite. If they can fit into another, then yes, you can divide. So the 3 and then can go into the 9, so you can still divide. If they can't fit into each other, then they're done. You don't simplify anymore. And if you do have a composite numerator and a composite denominator, you still have to see if you can still divide. Okay, so I'm going to pause for just a minute for you to write down these steps. All right. So the first 2 steps that you see off to the left there, right here. Oh, let me make sure I'm drawing. These first 2 steps is exactly what we did yesterday. Okay, no different than what we did. So we find the LCD by looking for our multiples. Okay, and then we change to the equivalent fractions. That's all that yesterday's lesson was. So today we're just going to add across the numerators, and you're going to see how simple that part is. And then we simplify if needed, which is why I'm giving you these notes, because I want you to remember that that's your simplification, whether you're done or not. Okay? So we're going to do 2 problems on this video together. I'm going to go kind of slow because I know a few of you were kind of struggling a little bit with these first 2 steps. Okay, so the first problem I'm going to do is 1/2 plus 1/6. Okay, so I would like to draw a picture to illustrate 1/2 plus I want to add 1/6. Okay, there's my 6th. So as of right now, I cannot take this 1/6 and put it over here because this is not equal to this 1/2. So I cannot add those together because they have different denominators. In order for me to put a piece with either side, this one here or this one here, they have to be the same denominator. So that's where I'm going to find my LCD. Okay? So remember that means I need to have my lists of 2 and my lists of 6. Okay? I like to do the first 5 multiples and then stop. And I can add more if I need to. So 2, 4, 6, 8, 10. And remember, if I do not know this off the top of my head, I can look at my multiplication chart, which I've shown you several times how you can Google. Okay, so then I have 6. Well, the first multiple of 6 is 6, correct? Now, I'm looking here and I see that there's already a common denominator. Okay, and since this is the first multiple of 6, then that has to be my LCD. Okay, because 2 can fit into 6. So remember, if I have a denominator like 2 that can fit into the other denominator, then this denominator is the LCD. Okay? Do I need to continue and do my list over here? No, I don't need to. Once I find the lowest, then I'm done. Okay? That's step 1. Now step 2 is to take the fractions and change to equivalent fractions. So I have 1/2 and 1/6. And I'm changing to the LCD, which is 6. Okay, and this again is about relationships. 2 times what is 6? Well, if I don't know, I can go up here and count. 1, 2, 3. So 2 times 3 is 6. What I do to the bottom, I must do to the top. So since I multiplied times 3, I multiply times 3 up here. So 1 times 3 is 3. Okay, I'm going to model this 1/2 into 3/6 over here in this picture. I'm going to change to a black so you can see this. So right now, I can see that this is 1/2, correct? Okay. If I take and split it into 6, like this down here, okay, I did not change what was shaded. All I did was cut up the pieces more. Okay, so this is equal to 3/6. Okay, you see that? All right, so then over here, well, if 1/6 is already in 6, then 1/6 is equal to 1/6. Okay, so that one doesn't have to change. So now if I'm looking at the picture, I can take this piece and put it up here, or I can take these 3 and put it down here. It really doesn't matter which one you do. So I'm going to take this one and I'm going to move it. And now it's right here. Okay, so it's no longer here because I moved it. So now what is this fraction? Okay, so this was 3/6 plus 1/6. So what is that a picture of now? 4/6. Okay, I'm doing that because I want you to understand that when I do this now, so I've changed it to the equivalent fractions over here and now I just rewrote it. Okay, I only add across the numerators because my denominators, remember, that tells me what each piece is worth. It tells me that this is worth 1/6. This is worth 1/6. This is 1/6. And this is 1/6. Okay. So I'm not going to add 6 plus 6 plus 6 plus 6 or even 6 plus 6. I see people do that. They tell me that the answer to this is 4/12. But that's not correct. Is this a picture of 4/12? No, it's not. Not at all. This is a picture of 4/6, and that looks entirely different than what 4/12 would look like. So it is not 4/12. It is 4/6. Okay, so we only add across the numerators. Now, this last part says simplify if needed. So this is what we were doing last week as well. So I'm looking at 4/6. And I need to see if I can reduce that anymore. Well, I know that both 4 and 6 are even. And if they're even numbers, it means I can divide by 2. So I can still divide that by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And now here's where I look at whether I have prime or composite. Okay, 2 is prime. Remember, that's the special one. That's the only even prime number. And 3 is also prime. So if it's prime, I'm done. So that means that 2/3 is my answer to 3/6 plus 1/6 in simplest form. Now, today, I realize that we're still working on the simplifying part. If you give me an answer of 4/6, I'm only going to give you half points. Okay? Because it says specifically simplify if needed. So it needs to be 2/3. 2/3 will give you the whole points, but 4/6 will give you half points. Okay? All right. So I accidentally cleared off all of the stuff that I had over here on the left, but you should have written that down when I asked you to, so you can look at your paper now. Okay, so now I am going to do the last one on this video. And this time, you know what? Before I do that, because we want to practice our estimating, right? So I'm going to go back to my 1/2 plus my 1/6, and that we just did. I'm going to estimate that, okay? And I remember that we said the answer was 2/3, right? So let's estimate and see if that's a reasonable answer. So remember, if I have a number line and I'm looking at a 0, a half, and a whole, okay, well, this is pretty easy because it's literally a half, right? So that doesn't even get rounded. That just stays as a half. So that one was easy. So now I need to look at 1/6, and see where that would go on the number line. Well, I know 0/6 is here. 6/6 is here. Half of 6 is 3, so this would be 3/6. Okay, so 1/6 would go about right here because it's only one piece away from 0. So I would say that this 1/6 would round to 0. So 1/2 plus 0 would be an estimate of 1/2. Okay. Now, if I think about 2/3, let me put this one in a different color. Okay. So 0/3 is obviously at the 0. 3/3 is here. Okay. Now remember, let's think about money for a minute. I have $3. Okay. Mrs. Higby gets half. Miss Stroba gets half. Okay. I know if I split this up into $1, $2, $3, okay? So here's my $3 I exchanged. I have $1 bills. I know that I can get 1. Okay? I know that Miss Stroba can get 1. And that leaves $1 left. Well, if I split $1 and divide it into 2, that gives me 50 cents. So I get 50 cents and Miss Stroba gets 50 cents. So that means half of 3 is actually 1.5. Okay, so I know this looks really weird when I write it this way, but this would actually be 1.5 thirds. Okay, so I have 1.5 here and I have 3 here. What I want to do is place the 2. So 2/3 would be about right here. Okay, and I can see that that is close to a half, which was our estimate. So that is a good estimate. Okay. All right, so now that I've done that, let's go to our next problem. Okay, and this problem is 1/9 plus 5/6. And I want to estimate first. Okay, so I'm looking at 1/9, and I'm not going to do this one on the number line. I'm just going to do my number sense. Okay, so I know that 1/9 is one piece away from being 0. So I'm going to say that this rounds to 0. I also know that 5/6 is one piece away from being a whole, because a whole would be 6/6. So I'm going to call that 1. Well, 0 plus 1 is 1. So I'm saying that the answer to 1/9 plus 5/6 has to be close to 1. All right, so the first thing I need to do is I need to write my multiples for 9 and 6. I want you to think for just a second. Think about what your prediction might be of what that LCD might be. All right, let's go ahead and try. So 9, my list of 9s would be 9, 18, 27, 36, 45. My list of 6 would be 6, 12, 18, I have one right here. Do I need to continue going on? I do not. Now I would eventually get to another common denominator because I know that if I do up to here, I would have another one, right? Okay, and I know that if I continued on beyond that, let's see, so that would give me 54, and then up here, if I went one more, it would be 54, okay? Now, here's why we do LCD, because I know some of you are in the habit right now of doing, oh, just multiply the two together, 9 times 6. Well, that is very true. That is a common denominator, okay? So if I do just say, oh, 9 times 6 is 54, that's what I'm going to change it to. You can do that. I'm not saying you can't do that. But if you do that, you absolutely positively will have to simplify, okay? So if you find this lowest common denominator, then chances are you won't have to simplify. So you kind of have, it's either find the LCD or simplify, okay? One or the other. So it's really up to you which one you want to do. Now, I'm not saying that every time you find the LCD, you won't have to simplify, because sometimes you will, okay? But I know absolutely for a fact that if you don't find the LCD, you will absolutely have to simplify, okay? So again, it's more, what are you comfortable with, okay? So now that I know that my LCD is 18, the next step is to take each of my fractions and change them to the LCD. So I have 1/9 that's going into 18ths, and I have 5/6, which is going into 18ths. So remember, this is all about my relationships. So 9 times what is 18? Good. What I do to the bottom, I do to the top. So 1 times 2 is 2. Down here, 6 times what is 18? 3. What I do to the bottom, I do to the top. So 5 times 3 is 15. Very good. Okay, so now I add them together. So I'm going to rewrite it over here. Now remember, we are adding across the numerators, okay? Because the denominators tell us what the pieces are worth. Okay, so I know I have all my pieces now are going to be worth 18ths. They are no longer 9ths or 6ths. They are now 18ths. Okay, so 2 plus 15 is 17. Okay, and now I see if I can simplify. Well, I know that 17 is prime and 18 is composite. So if I have a prime and composite, my question is, does one go into the other? So does 17 go into 18 evenly? It does not. So what that means is 17/18 is my answer. Now, let's evaluate that with our estimate. Is 17/18 close to 1? I would say yes, because in order to get to a whole, it's only one piece away. So that is definitely close to 1. Now, I do want to show you this, because I want you to know what this looks like. So let's say I go back to this theory up here of 9 times 6 is 54. And I'm going to change these to 54. I want you to see that you can get to the same answer. It just probably will be more work. Okay? So then 9 times 6 is 54. So then this is 6. 6 times 9 is 54. 5 times 9 is 45. Okay? If I add them together, 45 plus 6 is 51. Okay? Now, here's the tricky part, because I know a lot of you will look at this and you'll say, oh, 51 is prime. It's actually not. Okay? 51 is composite. 54 is composite, which means that I can divide them both by something. Okay? See, this is where it gets tricky, because if you don't know 51s and you're not comfortable with that, and it's not friendly to you, then you're going to say, oh, here's my answer. And then you're only going to get half off. Okay? So 51, I'm going to do this up here. I know, because I'm more friendly with 51 than you are, I know that both of these can be divided by 3. Because 51 divided by 3 is 17, and 54 divided by 3 is 18. So it's the same answer, okay? Same answer that we got down here. But I know that most of you will look at this and you will not know that you need to reduce that, okay? So that's why I'm saying do the LCD. Because did I have to reduce when I got down here to 17/18? I did not. Okay, so it's basically you either do this strategy, which some of you can do this in your head, so that's not a big deal. Okay, so it's this strategy, or you have to be able to do this one. Okay, which is not always going to be very friendly. So one or the other.